So the details are this. Remember, we said there were two steps. There was, first transcription, and that's taking the DNA and making it into mRNA. Okay, we talked a little bit about mRNA. Just a quick review. Remember that mRNA has a new nucleotide called a uracil, or a U, and it replaces what is T on DNA. So A and U go together instead of A and T. It also is single-stranded, and it replaces its sugar, which was deoxyribose here, with ribose here. Actually, it just adds an extra oxygen on there. Deoxyribose is removed. The oxygen is removed. Okay, so let's start with this part first, and then I'll go into step 2. So, I'll use a different color here, so the steps. Okay, so the steps are, step 1, the DNA is going to unzip. So the DNA unzips, but this time it's done by an enzyme called RNA polymerase. And like DNA polymerase actually makes new DNA. RNA makes RNA. Right. Okay. Good. Just make sure you're with me. Okay. So here we go. DNA is going to unzip. And we refer to this spot here, where it is kind of unzipping, if you will. We call that the replication fork. Which reminds me, what would you eat? How would you eat DNA if it were like spaghetti? Well, you would eat it with a replication fork, of course. Silly question. All right, number 2. Step number 2, we are going to, one of the two strands will serve as a template for RNA synthesis. So, new word here, template. Template, I always think of like a stencil. Stencil, it's like one of those things you cut out letters and you lay it down, and then you just color over the whole thing, and it leaves a perfectly, absolutely, even for my writing, perfect handwriting or writing of those letters. Okay, stencil's like a template. You can also think of it kind of like a photo negative. Those of you guys who know old school photo, not digital. Okay, it's the opposite. Okay, so all right, so. Go back to this here. So now it's completely unzipped, right? And we got our letters. One right here. Probably should make it a little bit longer. Not much of a DNA there. What should I got here? 3. Okay, so if I have that, we've got A, G, C, C, T, T, G, A. So on the opposite side I would have T, C, G, G, A, G, T. Okay, so let's say that this side here is going to be our template. This side here, so what letters will you put in these spots? Okay, so I want you to just pause the video, hit that button, pause, and fill in what would it be. Okay, and we'll be right back. Ready? Pause. Hey, welcome back. Did you try this out? How did it go? Hopefully you saw that this was a tricky spot right here, and so was this. These are those new nucleotides we talked about, the U. So this is now the new RNA. All right, so what happens next? the new mRNA has to leave the nucleus. You know, and at the same time as that's happening, we got to put back together our DNA. So, and the DNA zips back up. Okay. So, that's transcription in a nutshell. And I need to wipe this clean. Ready? 1, 2, 3. Hey. So, welcome back. Or, well, anyway. So now we have translation. So translation, we're going to take mRNA and we're going to go out into the cytoplasm where the ribosome is, and we're going to make our sequence of amino acids, and that will end up folding up into a protein. And you know, a little bit more about the proteins in the next step. So let's get some steps for this one. So our steps for translation. Okay, so step number 1. mRNA goes to the ribosome and is threaded through the ribosome. So a little bit about the ribosome. You know, remember, ribosome is made up of rRNA. I mentioned that earlier. We were talking about those 3 types of RNA, mRNA, tRNA. We still haven't talked about tRNA, but it's coming. And rRNA. rRNA is what makes up the ribosome. But there's 2 subunits for rRNA. The ribosome. There's kind of a small subunit, and then there's a larger subunit. Kind of forms a couple of spots in there, and through it we have our mRNA. And you know, this would be covered up. You know, I'm only showing it 2-dimensional. We sliced it right through. Okay. And so now step number 2 is we are going to look for the ribosome. Looks for the start codon. Well, okay, 2 new ideas here. First, codon. Let's put this down here. Codon is like a, you know, think of the DNA as a language. It's a message. So we got to have words in that message. And so far, we're just a bunch of letters that are A, T, or U, C, and G. You know, so codons are 3-letter words. In this genetic language. Okay, 3-letter words in this genetic language. It tells us, you know, what they mean. And more about that in a second. Now, start. I mean, imagine you got a letter, and it's just a whole bunch of letters, and in there, you start to see words, but it doesn't start from the right spot. So, what's it tell you to start reading a new sentence? Like a capital letter, right? Well, we don't have any capital letters, so in genetic information, or they're all capital letters, so what's the difference? So we have what's called a start codon. And codons, these are found on the mRNA. Okay, and the start codon is AUG. That's a memorized thing. Got to memorize that. There's one and only one start codon. Okay. All right. So now, number 3. Step number 3. For each codon, tRNA, there it is, the third one, brings an amino acid to the ribosome. And so for each codon, a tRNA brings an amino acid to the ribosome. And this is according, based on the codon. Alright, and I'm going to talk a little bit more about tRNAs in the next video. And how that all works. Okay, but we'll save that for this. Okay. And so there we go. Let's bring this little tRNA in here. And it has on it an amino acid, an AA. Okay? So these letters right here on this tRNA is an anti-codon, and on the mRNA there is a codon. And they match up, complementary base pairing rules. Same rules apply. A is going to go with U is going to go with A, C with G with C. It all works. It all happens all the time. Okay, and so this continues. Another one. Come in. And it's going to bring a different amino acid. And then these two will bond. And then everything's going to shift down. Well, actually, it's the ribosome that's going to shift this way. And the next one will come in. And then it'll bond. So now we'll have like 3 amino acids. And then everything shifts down. Or the ribosome shifts over. And this tRNA leaves. Yeah, I didn't mention that here. tRNAs, once it's done its job, it's out of here. Okay? This continues and continues and continues. And pretty soon you have this big long string of amino acids. Remember, amino acids are the building block of proteins. Okay? So, I'm going to put this up over here. So number 4, this continues until you reach a stop codon. Well, what do you think a stop codon does? It tells it to stop. If this start codon was the capital letter of the sentence, stop codon is the period. Done with the sentence. Protein is complete. And so what that does is it brings in this little different kind of thing here. It's called a little release factor with no amino acid. And it will come in and it breaks the whole thing apart. And so what we're left with is the mRNA. We have a whole bunch of empty tRNAs. We have a string of amino acids which are ready to fold up. But more about that on the next lesson.